Well, welcome everybody to another Beers with Engineers session. Um, we'll kind of go through our standard preamble before we kind of get into the meat of the agenda for today. So as always, we sometimes talk about forward-looking features on roadmaps and things that are coming but not fully baked into the product yet. So always take that into account and don't make purchasing decisions based on any roadmap or forward-looking items that we mention. Our informal agenda, as usual, we'll just introduce ourselves, talk about why we get together in this forum every month. We'll do some, we'll dive into a couple technical topics, and as always, you don't have to wait till the end for Q&A. Feel free to come off mute or put questions out there in the chat or the QA whenever something comes up. Happy to explore tangential queries at any time. Why are we here? So in the context of Beers with Engineers, the answer to this existential question is that our goal when Mike and I started having these little get-togethers was just to have some kind of a forum where ServiceNow employees and customers who are exploring the cloud native world and on somewhere on the journey towards transforming their digital infrastructure into that cloud native landscape, to talk about the challenges and discoveries and innovations that they've been able to create, and all the while trying to cast that against the backdrop of the ServiceNow platform, to try and show different ways that the platform can make that journey easier and in many cases accelerate it. So some intros. So Mike, if you would like to let us know who you are.
For sure. So Mike Gallagher, I am the manager of the Enterprise Application Platforms team here at DRW. Previously a ServiceNow employee. I have been in tech for longer than lots of folks have been alive. And I am just generally an all-around nerd anyway. I absolutely love all things Kubernetes. I'm a big proponent of IT operations management, and I love to basically tinker with anything and everything that I can get my hands on, specifically in the cloud native space. I actually play a lot of board games and some video games, and I would be lying if I said that I hadn't lost quite a bit of sleep to Baldur's Gate 3 recently. So, and today I am actually going to change it up quite a bit. I am having an Ace Guava cider. It's a craft cider, so I'm gonna give that a shot.
Nice.
Will?
Hi, I'm Will Hallam. I work at ServiceNow as an advisory solution architect focusing in the ITOM areas. I've been working in technology for quite a while. Lately, I've been focusing a lot on automation, and specifically in various cloud native areas, Kubernetes, serverless stuff, the various public cloud providers, that kind of stuff. Really enjoy and find it gratifying to find ways to automate repetitive tasks. I've never been a fan of doing the same repetitive mundane task more than a couple times. And in my spare time, I just like to hang with my family. I play some pickup hockey and probably too many video games than I rightly should. Today, I'll be enjoying a Fiddlehead IPA from Fiddlehead Brewing in Shelburne, Vermont.
Nice.
Okay, so because I want to make sure I didn't forget to bring it up, before we kind of dive into our technical topics, I did want to bring up the fact that we are I know I'm currently on the hook. I'm going to definitely be at Kubecon. I've made my travel arrangements. Mike, I'm not sure where you're I know that's kind of your backyard from an employment perspective, but I don't know how solid you are for definitely being there. But we're looking at doing, for those of you who attended our live event at Knowledge this year, we're looking to do something similar to that at Kubecon, which is in Chicago, November 6th through the 9th. Still kind of early discussions as far as what form that will take. So the topic's TBD. Just really interested, we, kind of wanted to throw it out to this community, let you know that that was in the works, garner some feedback if there was, if you're planning on going to KubeCon, or if you've got, peer organizations who are planning to attend as well. And just say, do let us know if that would be of interest, if you're going to be there, so that we can kind of feed that back to the folks that are putting the planning together for the ServiceNow presence at KubeCon, and use that to kind of shape what form the, the Beers with Engineers contribution to our presence at KubeCon takes.
I'm excited about that, and I likely will be able to attend, but I have not finalized that yet.
Okay, cool. Yeah, if nothing else, I'm going to be on the hook for, ServiceNow is going to have a booth, and I'm on the hook to spend some time in the booth talking, kind of focusing on that Kubernetes observability and ITOM, so like AI ops, event management, better together story. So that's kind of what I'm definitely going to be doing. And then the more kind of Beers with Engineers focused piece is still getting kind of discussed. Okay, tech deep dive. So what we're going to touch on today is a couple updates in the service graph connector space that we touched on in previous sessions. The first of those is going to be the actually the topic that we explored with Clay Smith from the product side at Knowledge. And that was a really great time. Unfortunately, the logistics didn't work out really well to like do any kind of recording. So for those folks who weren't able to go to Knowledge 23, they may or may not have had much exposure to this new service graph connector up till now. So we wanted to touch on, now that it's GA, it's actually at version 1.2. Version 1.3 is coming soon. And that's part of and part of that process is the product team is looking for feedback from customers after they kind of kick the tires on the current iteration, to kind of help guide those last sets of features that they're working to put into 1.3. So it's definitely kind of a very open dialogue right now on the product side with what the next, iterations of the service graph connector are going to look like. So if you've got particular feedback in that area, definitely funnel that back. You can send, as always, communicate that back through this forum, or, certainly with your, with your ServiceNow account team. So a couple slides to show the highlights of what's in the current version. It leverages ServiceNow Cloud Observability, which was brought into our family by way of the purchase of Lightstep. But this functionality does not require any kind of separate entitlement to the observability product. The only caveat there is if you want to integrate with event management and set up thresholds within cloud observability, you do need a separate cloud observability entitlement for that. But to get the functionality that the service graph connector provides in the form of ready-made service maps, if you've got OpenTelemetry instrumentation, either explicit or auto instrumented, as well as a pretty turnkey mechanism for discovering just your Kubernetes clusters. So if you're an ITOM customer, ITOM Viz, you can use this capability without having to have any separate entitlement in the observability space.
And effectively, the way to think about it is the capabilities that you get out of it are aligned with the license that you have today, right? So if you have just visibility, then you're only going to get visibility into the Kubernetes clusters. If you have health, you can get the health data, but will also require the ServiceNow observability, cloud observability license as well on top of that. So,
Yep,
just to clarify.
spot on. I mentioned turnkey installation. So the form that takes is there are ready-made Helm charts, which can deploy this capability into a Kubernetes cluster with some reasonable default values. It's also got in kind of, it's a theme with OpenTelemetry where and Kubernetes, where it is very customizable. So it's kind of a fit if you're greenfield and you don't have any OpenTelemetry in your environment today. There's reasonable default setups that you can deploy to those clusters pretty readily. But if you're already, on a path to using OpenTelemetry, you can also just kind of tweak those existing OpenTelemetry deployments to then just essentially just fork off a stream of that data into the ServiceNow Cloud Observability backend to generate the needed metrics, which are then imported by the Service Graph connector to generate your, to populate your CMDB, generate your service maps. So,
yeah, and I actually, when I was doing my initial testing of this, I took that Helm chart and hacked it up and deployed it in a full-blown like GitOps model and was able to get it working pretty well that way. So I was actually pretty impressed with it. Sorry, continue.
So without any instrumentation at all, if you just install this in an empty, pristine Kubernetes cluster, what it'll do is it'll collect cluster node, pod service, and workload information. It scrapes those out in the form of metrics, which then get sent to that cloud observability backend, and then the service graph connector piece has import jobs on the ServiceNow instance side, which import those in the form of corresponding CIs. So you end up with, a CMDB populated with those basic Kubernetes components. Then if you've got, if you have workloads that are running on things like Java, .NET, Python, you can pretty readily activate OpenTelemetry auto instrumentation. And what that means is basically the OpenTelemetry collector can retrieve not just those metrics, but also traces from those workloads without having to make any changes to that code. You basically add an annotation to the Kubernetes manifest, and then the OpenTelemetry collector will extract those traces without having made any changes to those workloads at all.
Only in specific supported languages, though.
Yeah, it's Java, .NET, Python, and I think there's one other one I can't remember off the top of my head.
Wasn't it Go? I can't remember.
It might be Go. I mean, that would make sense because Go's a very kind of staple language in the Kubernetes space and the OpenTelemetry space.
But we can confirm that.
Yeah, and actually, one of the links that's included in our deck that we'll send out as part of our follow-up emails, there was a really great lab that was run by one of our observability SMEs at Knowledge, and he put the collateral, the materials from that lab into a public Git repo, which basically walks you through creating an example environment within a Kubernetes cluster that includes auto instrumentation as well as an explicitly instrumented example application. And so I'll provide the link to that public GitHub repo. I found that to be really useful in my own testing environment that I ran with this service graph connector. So in addition to auto instrumentation, if you've got applications which are explicitly, include those OpenTelemetry instrumentation calls already, then certainly you can tap into those. That's kind of the ultimate end goal on a roadmap of implementing OpenTelemetry, because that's what really gives you that very granular insight into what's going on. And I'll kind of show you in a couple slides what that looks like on the ServiceNow side, and show it side by side with what you're seeing real time within the cloud observability space. And it really provides a very detailed service map on the ServiceNow side to really kind of show you what those interactions and relationships are between various microservices. So there is a new release. Like I said, they're working on version 1.3. They're targeting end of year. One of the main features they're adding to that is to expand the CI classes that are captured by the Service Graph connector. And what I mean by that is they're looking at things like cloud VMs. So if you're running a Kubernetes cluster, the goal is to not just show you the Kubernetes nodes, but to actually take that one step further and show you the underlying, if you're in AWS, show you the underlying EC2 instances that are running, and kind of close the loop with regard to that overall picture of what infrastructure is hosting these workloads. And the product team is still soliciting for customer feedback there. So if you've got particular CI classes that you would be interested in seeing come through as part of a, discovering a containerized workload, definitely funnel that back through the channel of your choice. So this is a slide we brought over from our time we spent going over this at Knowledge, and it really is just meant to capture where the pieces, how the pieces fit together. So on the left, you've got the kind of the three types of OpenTelemetry data: metrics, logs, and traces, funneling through OpenTelemetry infrastructure, ending up on the cloud observability backend. And that's providing kind of the ability to near real time interrogate what's going on within these workloads. And then from there, you can establish thresholds. If you've got a full-blown cloud observability entitlement, that's what lets you set thresholds. So you can say, if latency goes above this many milliseconds, for example, then you can make a callback into your standard ServiceNow event management setup to then trigger alerts, which are then correlated with other sources as per kind of standard AIOps and event management functionality that you'll find within the platform. And then the other piece down below is where the Service Graph connector comes in, feeding the metadata into the CMDB, so that when you get one of those alerts, you're not just seeing, oh, this particular container is, or this particular microservice is having an issue. You can see the full business context within the service map on your ServiceNow instance, and see all the way up to, here's the business owner, the business leader who's going to be impacted if we don't get this situation resolved before it causes some some negative customer interactions.
One quick key thing to point out as we're talking about like maintaining control of access of the data and where things are going, that cloud observability platform is actually exists outside of the ServiceNow data centers, and actually lives on kind of a custom like GCP instance. So something to be aware of if that's a concern for you, just to understand that that's where the architecture lives. For lots of customers, it's not a problem. For us, it would be a problem. So it's,
That's
just
right.
something to
That's
be
right.
aware of.
Yeah, I had kind of forgotten about that. Yeah, that's a great call out. So the cloud observability platform does still live in GCP, and that does present a barrier to entry for some. So it is something to be aware of when we're talking about this capability and this Service Graph connector.
Yep.
So this slide is just meant to capture the general kind of the way it's constructed. and kind of the high points. So as I mentioned, there's Helm charts you can use to deploy this, the Kubernetes side of the, basically there's actually an OpenTelemetry operator, which can take care of some of the heavy lifting with configuring the collectors for you. Make sure they're running the latest version at any time. And when you update parameters, it automatically refreshes the pod. So it's a great way to kind of have more of a set it and forget it setup, especially if you're in kind of that more greenfield environment. But it is optional. You can also just roll your own OpenTelemetry collector configs and use that as the mechanism for sending the streams into cloud observability. And then, we'll touch on, when we get into the platform, we'll touch on the, you've basically got import jobs that are running transforms and making API calls into the cloud observability backend to pull in the data about the different CIs, and also capturing those service to service relationships. And that's kind of where that's a big differentiator, where with traditional Kubernetes discovery, you were mostly going to be relying on tag-based service maps to draw those connections between different Kubernetes components. And this capability gives you additional insight without having to collect any new data, because of the fact it's kind of sitting on top of the existing OpenTelemetry instrumentation. So, Mike, if I remember correctly, this was when you were kind of looking at this capability from a customer perspective. These were kind of some points and questions that you came up with from the customer perspective that you thought would be kind of key to touch on as somebody who's looking at this capability and then marrying it up against where they were with regard to Kubernetes cloud native within their environment.
Yeah, it's really, a combination of that and like some of the thoughts and concerns, right? So, like when you stop and think about how you're using the data that's populating the CMDB today, this is really thinking about the OpenTelemetry components and this service graph connector, and how does it kind of fit into the broader picture. So, the first quick, easy question to ask is, do we have OpenTelemetry already either deployed or on the roadmap, right? Because if the answer to that is yes, then there's definitely some quick, easy ways that you can kind of show some value, get this thing deployed, and start pulling in that data from OpenTelemetry. And then, the real answer from that is, okay, where is that quick win? Is there a particular, service? Is there a particular cluster that's already instrumented properly that we can kind of go and do, like a quick POC on and get that value showed, right? The other thing is, if you're using other service graph connectors already today, right? There would potentially be some overlap in kind of the methodology and the understanding and the fact that those are already, coming into the IRE, and may also be able to like help populate and broaden the data that you're getting across OTel versus other sources, right? The other thing to think about is, like, do you have somewhere else out there where you're building out maps of your cloud native environments, right? Some cases that's a yes, some cases that's a no. And the capabilities can be wildly and dramatically different across different solutions, right? So being able to kind of populate all that data into the ServiceNow CMDB and getting it done based on actual real utilization and traffic across those components can be really, really powerful, right? And this gives you data around, like, hey, what's the current state? What's the current sort of visibility and capability level across your environment? one of the other key questions to ask is if we're already ingesting Kubernetes CIs from other different methods, how is this going to reconcile down with those other methods? Should we be turning off those other methods and just in favor of OTel? Or should we kind of tweak and tune the rules to ensure that we're augmenting that data set all across the board? And then kind of last but not least, is there any way in place today to be able to determine, hey, here are the components that are running in a cluster and its infrastructure that's underlying underneath of it, right? That's definitely something that this can help with, that a lot of organizations struggle with all day, every day. There's always that sort of division between, like the devs and the infrastructure operators, and the devs just care about what's going on in the pods and the services. They don't care about anything else, right? So this kind of like ability to have that full scale 360 view is really powerful. Yeah, so those are the kind of key common questions to stop and think about.
All right, so just to give you kind of a glimpse into what this service graph connector looks like when you've employed it in your environment. So here's an example of how you can deploy this pretty readily against. So I did this with a couple Kubernetes clusters, one that was kind of just pristine with nothing running in it. So you can kind of see what you get, even if you've got like zero OpenTelemetry instrumentation anywhere. And then I did it in a cluster that actually had an example fairly robustly instrumented OpenTelemetry example app deployed to it. So you can kind of see the difference. So this is that GitHub repo I mentioned. It's really useful because it's got just kind of a step-by-step set of instructions right down to the Helm commands that you would run to deploy this into a cluster. I guess for the lab, they use DigitalOcean to provision the clusters themselves, but I used Amazon EKS and didn't have any issues. So it seems to be pretty agnostic as far as that's concerned. So yeah, I mean, just, to really quick touch on what it takes, there's this set of Helm commands here, basically to pull in some repos. It does rely on the cert manager Helm chart to manage the TLS certs that it uses to talk back and forth with the observability backend. It seems like this is pretty commonly in use out in the field anyway. In fact, our new automated Kubernetes certificate management offering also makes use of the cert manager Helm charts. And then you just install this OpenTelemetry operator. Again, it's not required. It just makes things a lot easier. Operators in Kubernetes they're basically kind of like wrappers that provide automation around lower level, deploying lower level workloads. And so what that looks like on this, when I deployed this against a very generic cluster, is I get this CI and related CIs in the form of, I've got my list of pods, my list of services, namespaces, and then various, payload or workload types, deployments, replica sets, stateful, daemon sets. And I basically got this all just by deploying those Helm charts and then running through the guided setup for the service graph connector itself, which is fairly minimal. Essentially, the main thing you have to do is, it does rely on the cloud observability product. So if you want to look at this, you can either go self-register for an organization within the Lightstep platform, or your ServiceNow account team can facilitate that for you and basically just give you, basically set it up for you and give you the, the login credentials that you need to get into that. So once you've got that organization set up, that'll come with an API key, one or more API keys. You plug that into the Service Graph connector configuration. And it's a standard, it's a standard credential type record. And then once you do that, you just go to the next step to test the connection. And when that connection tests successfully, it allows you to pull in the container that Cloud Observability uses to collect pieces of a workload is called a project. And so what that does is once you've got, a successful connection, the guided setup will go through and connect to your Cloud Observability organization and pull down a list of all the projects that are currently there. And that's what we've got here is a list of all the projects that are in my test organization on the Cloud Observability space. And so after that's set up, it's really just a function of scheduling the import jobs to run on the cadence that you want. And then those just kick off and pull down updates from the Cloud Observability backend based on the frequency which is desired. And so what that looks like when you've got a fully instrumented OpenTelemetry compatible application is something like this. So this is the Lightstep, formerly called Lightstep, now called ServiceNow Cloud Observability UI. And what you're seeing here is the service diagram that the observability platform creates in real time, and it'll kind of regenerate that dynamically. This happens to be a latency histogram. So if I want to see the services that are involved for kind of my most, my highest latency types of interactions, it'll generate that diagram kind of on the fly and show me the different services that are interacting. And what this service graph connector does for you is it basically produces a very similar service map to that dynamic service map that you get on the observability side, but it lives within your CMDB. So if my product catalog service is experiencing an issue, I can see all of the upstream and downstream impacts that that could have within the ServiceNow platform. Okay. I always forget to hit the start at current slide
Right.
when I start the presentation back up.
While he's getting back to that slide, any questions or thoughts on the OTel piece before we shift gears? Don't be shy.
So this QR code that you'll see in the deck, that's the quick link to the store page. If you would like to download it and try it. And as I mentioned, there is that kind of self-provisioning piece on the observability side that account teams are totally on board to help with. So don't let that be a barrier to entry. If it is something you'd like to look at, they can help you to get that observability organization set up with without any overhead on your part. So the second big service graph connector update that happened over the summer and had a bunch of new stuff that it brought to the table was the 2.0 for the AWS Service Graph Connector. And we had Murley from the product team come and kind of give us a preview of what was coming with that. And now that it's actually out, it's actually up to version 2.2. And they've added some even cooler stuff like EKS support, which I think is really cool, because when also in the same time frame, we released the 1.0 of the GCP Service Graph Connector. And when I was playing around with that, one thing that struck me was, hey, GCP actually exposes Kubernetes cluster information via their native cloud API. So just by doing that Service Graph Connector, you could all of a sudden get a lot of Kubernetes CIs into your CMDB without having to ever set up any separate Kubernetes discovery. And I thought that was really cool. I suspect other customers thought it was cool and asked, hey, can we do this with AWS? And unfortunately, there was a little more work involved there, because AWS doesn't expose that at the API level like the other two big players do, because it looks like Azure does as well. Like I can go into the Azure portal and see Kubernetes namespaces and pods and stuff. So anyway, with version 2.2.0, we now have the capability to look into EKS clusters with just the Service Graph Connector. And there is some setup involved, and we'll get into that in a minute. A big plus for this new iteration is multi-instance support. So that's not only can you do, it's kind of like sky's the limit. You can slice and dice it however you want now. Previously, you had to basically start your AWS discovery via Service Graph Connector at your top level org, your AWS organization. You had to have some access to your master AWS account. And if you didn't have that, you couldn't set this up. Not only is that no longer a requirement, but if you've got multiple AWS organizations, you can actually set up multiple instances of the Service Graph Connector within your instance now to walk across multiple organizations. As I kind of touched on, you can also install this to a single account. And speaking selfishly as a solution consultant, this was huge for me, because up until this version came out, I couldn't even demo this tool for customers because I don't have any access to the ServiceNow main billing AWS account. So I could not get this thing set up in my demo instances. From a customer perspective, it makes piloting and kicking the tires on this infinitely easier, because all you need is just a regular sub account within AWS. You don't need any access to that AWS organization in order to test and validate all of the functionality that this Service Graph Connector offers. Automated key rotation, super handy. One of the hitches that you could run into from time to time when you're talking about the Service Graph Connector is the fact that, unlike pattern-based discovery in the cloud, you couldn't just use like a mid-server role directly. You had to have that initial API key to let you to kind of establish that initial connection, and then you could assume roles from there to hop from account to account, but you still needed that kind of that bootstrap credential. And in this day and age, the idea of, kind of static API keys and secrets is a little anachronistic. It's not generally what people would prefer to use when it comes to, API access to discover their cloud accounts. The automated key rotation, I found it works really great, and it mitigates the use of those kind of static credentials, because in my test environment, I just set it to a 1-day life and it just rotates the credential every day. No problem. And then EKS support, again, that was, I saw in some of the community articles that Murley put out there, where he really got in deep about the different configuration parameters for this Service Graph Connector, because it is very flexible, especially now. There were comments saying, hey, can we get EKS support? Can we get EKS support? And now that's there. And it really, I think I think on the one hand, we've got a lot of options now to discover Kubernetes, right? On the other hand, if you're just starting down the journey and you're going to set up a service graph connector anyway, the fact that you can now pull in at least your basic Kubernetes objects without having to go through any other setup for any other capability, I think is a big plus, especially given the fact that, you know, GCP, it's there with GCP today. And it didn't look like the Azure Service Graph Connector did it yet, but Azure definitely makes those details available via API. So adding that to the Azure Service Graph Connector is a fairly straightforward exercise because all the metadata is already available via cloud API calls.
Yep.
So just touching on some of the benefits, yeah, multi-instance support. It's just, we've got big customers out there who have multiple orgs. You know, they'll have like a prod org, a non-prod org, you know, gov cloud org, non-gov cloud, you name it. So now that's no longer a barrier. There's a separate set of the guided setup that lets you add additional instances, whether it's standalone accounts or separate AWS organizations. Installing into a single account, great for pilots, great for kind of evals. It makes that whole process a lot more agile, especially when it comes to debugging AWS permissions, which I don't think I've ever deployed anything to AWS where I didn't have to kind of poke around with permissions to some degree to get it to work exactly right. So the ability to just deploy that all self-contained into a single account before you have to worry about stack sets and deploying it, you know, organization wide, it can be a real big streamlining factor. Again, great that now your solution consultants can demo and test it for you much more easily is awesome. Lower complexity to implement on a small scale. If you just have some targeted deployments that you need to run this in, you don't have to boil the ocean anymore and handle it at a AWS org level.
Yeah.
The automated key rotation, it is optional. You turn it on, you turn it off. I found that I did have to tweak the permissions a little bit because, and I'm not sure if it's a bug or a feature yet, but so you've got your basic, like your service account, that's what has the API credentials. And then the service account has the ability to assume a role. And the role is what generally has the bulk of the permissions that are required to do the discovery. Maybe because it's a fairly new feature, what I noticed was when it's running the key rotation, it's not assuming the role. It's running the key rotation commands, API calls as the service account directly. So I had to add the create access key, delete access key permission to the service account directly, as opposed to it's already actually in the role because we provide CloudFormation templates to create the role for discovery, and that's already got create access key, delete access key. I had to add it to the user in order for it to work. So that may be an errata that's just going to get fixed, but something to be aware of if it is something you want to take advantage of immediately today. The user configured frequency works great. It defaults to, I think, 90 days. I just cranked it up to 1 day because I was testing it. I wanted to see it work. And I checked today and my API key is like 12 hours old as of now. It's a scheduled job. So obviously you can run it on whatever cadence you want. I think the granularity for the property, the property of how often to change it, I think it's in days though, so it doesn't make a lot of sense to run it more often than once a day. The EKS support is it piggybacks off of the existing systems manager functionality, which has been in the Service Graph Connector for a while now. So that uses systems manager to gather things like the software inventory, as well as to run some local commands so that you can get things like the serial number, the OS level serial number from EC2 instances without having a mid server in the environment, which would normally, you know, SSH or PowerShell into those boxes. And so you do need that. That's an optional feature. Like you don't need to have that set up to run the service graph connector. But if you want the EKS support, you do have to have that SSM stuff set up, which is basically you're giving systems manager permission to run some specific commands. And then you set up an S3 bucket to store the output from those commands, because the output can be larger than it can return back in a single kind of in an interactive API call. So what it does is it stores that output in an S3 bucket, and then the service graph connector retrieves the output from the S3 bucket. So it uses a similar functionality. You just add a couple additional commands to what that systems manager agent can run. And it just uses, it basically uses kubectl on a Bastion host to retrieve the information from the various EKS clusters. So you heard me say Bastion host. You do need at least one EC2 instance that has the ability to connect to those control planes that the EKS clusters are standing up. So, worst case, if you're very segmented network and you don't have a lot of, you don't have like a transit hub that facilitates communication to those different control planes, it could end up you need a lot of bastions. I would say if you're looking at that kind of situation, it would definitely warrant trying to maybe look into something like a transit hub or something to kind of make those endpoints more centrally accessible, and then limit the number of bastions that you need to provision. That's definitely kind of a feature where it's not very attractive probably to have a whole bunch of separate bastions, but the solution itself does support that. It lets you create records for each bastion, and it kind of maps them to each cluster so that it can handle a many-to-many relationship without a problem. It's really more on the kind of the setup side that you'd probably want to minimize the number of bastion hosts that you need to allow this EKS support capability to function. And there's a dedicated knowledge base article for the EKS support. There's a link included in the deck that we'll send out with all our slides, because that's really key and using to get the things set up. I did run into a bug, checked with support, and there's an active PRB record for it, and it's going to be fixed in the upcoming version 2.2.1. Has to do with when it pulls in namespaces. For whatever reason, the namespace records come in and they don't have any name for the namespace. So you see a bunch of dependencies on a namespace record, but it doesn't tell you what the namespace record, the name of the namespace is. Also, there was a script include that I noticed. There was a script include that is responsible for downloading the output from S3. And so basically what happens is it runs a job to kind of run the commands and dump the output in S3 bucket. And that's asynchronous. So then what it's supposed to do is it's supposed to check the S3 bucket and then just kind of loop until it sees that output file show up in the S3 bucket. The problem is this script include that I call out in this slide was checking, it wasn't checking for a 404, it was checking for a 403. So the problem was it was getting a 404 and it was bypassing the retry and immediately just saying, oh, I can't get the output, and it was bombing out. So I've got a case open on that as well. But in the interim, it was pretty easy to fix that. It was like just one line in a script include to fix that and then get my output downloading successfully. And so right now, what it looks like is it's pulling cluster, node, pod, deployment, and service CIs. But as I mentioned, it's just pulling like YAML format or JSON format payloads using kubectl commands. So it's pretty extensible in the short term, and I'm sure in the long term, they're going to just keep adding additional CI classes as the product matures. So just a couple looks at what that looks like on platform. So the guided setup, as I mentioned, here's like the monster kind of one size fits all configuration page that we have now for this service graph connector. And it's basically intended to account for all the possible scenarios. So you don't have to fill out every single one of these forms. It's really dependent on what your specific setup looks like. And there's also a detailed community article about all of this. There's a link to that on the links page that'll be going out in the deck. So don't feel like you've got to kind of absorb all of this. Just wanted to give you kind of a look to how it's set up now with this generation of the tool. So the two things you have to give it are a connection alias and the name of the role that it's going to assume. This section here, I'm running in a standalone account, but as part of the multi-instance support, they added basically the ability to tag a given instance with an organization, some type of an organization. I used my account ID and just made up a name so that when you run the diag tool that they give you, you can select which which tenant, which instance you're running against for it to do the validation. And then, yeah, I mean, it's really, because I use the systems manager setup because I was testing the EKS functionality. I did fill in my S3 bucket. These values down at the bottom come with defaults, so I just left them, and those are the names of the what are called the systems manager documents, which contain all the shell commands that are executed for the this is for the Linux and Windows discovery to pull things like the serial number information. And then these are the two documents that contain the shell commands that are used to list all your EKS clusters and then interrogate each EKS cluster in turn to pull down basically this big dump of all of the metadata containing the CI classes that are currently imported by the service graph connector. So here's an example of a EC2 instance that's inventoried by the service graph connector. And so because I've got the systems manager inventory enabled and I've got my systems manager run command capability set up, it actually can pull down some of this related data that normally you'd need a mid server for. So you can see I've got the running processes listed as well as the software inventory on this Linux server, which is running on an EC2 instance. And in terms of what a Kubernetes cluster looks like, let's see, bring that up. So this is my EKS cluster, and when it fleshes out the relations, you'll see that it's filling in pods. It's got my node information down here, as well as service CIs. One thing I did observe today is it looks like right now, and I just kind of ran into this right before we started up this session. It looks like it might be combining stateful sets into the daemon set CI class. So I'm going to follow up on that. It looks like I suspect that's probably just a bug, which is going to be fixed with the upcoming 2.2.1, because it's kind of like a 1-for-1. When I look at, if I just look at stateful sets, I think the table's like empty, but if I look at my cluster, I've got stateful sets in there. So the fact that they're not coming in, but if I look at daemon sets, I remember correctly, there was a whole bunch of them. But when I look on the cluster, there's definitely a lot fewer showing up on my cluster than I'm seeing in CMDB. So I suspect that they're just kind of conglomerating multiple workload types under daemon set when it's stateful sets. Oh, and replica sets. That was the other one. I think most of what I've got is a replica sets because that's kind of the subordinate workload that whenever you do a deployment that gets created. So I think if I look at the cluster, if I look at replica sets, it shows me a whole bunch. But within the CMDB, everything seems to be, right now, it seems to be kind of merging it all, sticking it all under daemon set. So that was a little bit of an errata that I did notice. I don't anticipate that's going to be difficult to get remedied, though. Another helpful link, just kind of as a shout out, as I mentioned with AWS, a lot of times permissions can be a bit of a bear. So I did include a helpful doc link to an easy way to query CloudTrail API logs, which I found really useful when I was kind of walking through setting this up. The diag tool is great. It'll tell you this permission failed, but it won't tell you why, or won't tell you exactly like what role was being used, verify that it assumed the role, that kind of thing. Whereas when I was able to query the CloudTrail logs, and a lot of companies have, user-friendly ways to do that anyways, but if not, I included a link that makes it kind of easy. If they're getting dumped into S3, you can use Athena to query those logs and see, show me access denied against S3, and it really lets you home in on where the permissions are running into trouble. So we traditionally run for an hour, and we're at the top of the hour, so I want to be respectful of people's time. I am not constrained, so I'm certainly available. Mike, I'm not sure what your schedule's like today, but
I'm free.
Awesome. But yeah, I don't think I had any other kind of points that obligatory points I wanted to make sure that I touched on. So certainly happy to dig into any of the stuff we've talked about today further, or completely go off on a tangent if folks have questions or topics that they want to air in this forum.
And we should probably conclude the recording at this point.
Yep, good call. I will do that.